I have a question.
Yeah.
If I broke it down in 2 times 3 times 3,
Sure.
it's
Okay.
okay?
But hopefully you wouldn't do that if it was 2 times 3 to the 5th or something, or, yeah.
Yeah, no.
Okay.
It's only because.
You do have to be able to apply that exponent directly.
Okay.
I like it, okay. Okay. So, was there part F? Yes. Oh, cool. What the hell is that thing?
I have no idea.
I don't know. Oh, yes, that's right.
Any number?
You ready? You ready? Now watch. Somebody help me out. Does anybody remember what is x squared divided? Let's do this. X cubed divided by x squared. Somebody remember how to do that? Watch this. What's x cubed mean?
3x's.
Yeah, 3x's multiply. And x squared is 2x's. How many x's cancel? 2. So what's left?
1.
So the shortcut is 3 minus 2. So some people might say, well, how did division become subtraction? That's not at all what I'm saying. 3x is on top, 2 on the bottom. 2 cancel, so that is losing 2 x's. So the shortcut is when you divide like bases, you can just subtract the powers. Does that sound at all familiar? We will focus a lot more on power properties later. So if you don't quite get that, hopefully it kind of sounds familiar. How do I make the power become, right now it's a 1. What would I have to put down here on the bottom so it becomes a 0 at the end?
3.
Also a 3, right? Because what's 3 minus 3? Frickin' 0. But what is something divided by itself?
1.
1. So anything to the 0 power is 1. And really, now watch. So isn't x squared x times x, right? And x cubed would be x squared times x. Cool? So let's think about this backwards then. X squared is this times another x. Well, where did x come from? X came from 1 times x. So if I have no x's, I must just have that 1 that's always there. That must be the only thing there then. Because really, if I say x to the 0, I'm saying I have no x's. So what do I have then?
0.
The 1 that's there always, not 0.
That's all you want.
There's always that 1 hanging out, so he has to show up now because there's no frickin' x's. This is a very dumb way of saying, I got no x's. Why would you write x to the 0? You're just going to write 1. That's if you got no x's. How are we doing? That's another way to look at it. I already proved why x to the 0 is 1 here, but I'd like to give you another way to look at it also. And here's another thing. What's the only thing I can multiply by? And the result is the same as what the thing used to be. So what do I multiply 7 by to keep it as 7?
1.
Okay. So is there any other number that can do that? Can I multiply 7 by anything else and it stays the same? Everybody with me? That's the only thing. So help me out. What is x to the 0 times x to the 7th?
1.7.
What do you do with the powers? You just add them. And what's the only thing that I can multiply something by and it stays the same? 1. So that's another way to look at why something to the 0 power is 1. So what's 4 to the 0 power? 1. 1 minus 3 is?
2.
Careful. Negative 2.
Negative.
Because the bigger one is 3. So I got $1. I owe you 3. I can give you my $1. I still owe you 2. Shit. Okay, I like it. Maybe? You guys all right? Okay. All right. So the last couple here. Go. Number 3. So now we got the real thing about math. We should all know by now that math is a foreign language. So there's a lot of translation issues. And that, of course, is the big barrier between word problems and understanding, right? So these aren't really word problems yet. These are just little baby things. But so the most evil phrase in English when I'm trying to go to math is less than. 5 less than 3 is not 5 minus 3. Right? So for example, just tell me, what is 2 less than 10? What's 2 less than 10?
8.
8. Is everybody cool with that? Of course it is. Did you just do 2 minus 10? No, you did 10 minus 2. Do you see that? Less than is the only phrase that you actually have to write the reverse of what it looks like in English. So 5 less than 3 should be written as.
3 minus 5.
Now, is anyone concerned about, now we're not done with that obviously, but is anyone concerned with why I didn't write that maybe like this? It's okay if you are. Maybe you're right. Maybe I just had a brain fart. You're wrong though, because how do you say this?
5 is less
Is.
than 3.
5 is less than 3. That's the inequality. 5 less than 3 is a difference. It's a subtraction, right? Okay, I like it. So what is 5 less than 3? What is 3 minus 5?
Negative 2.
Negative 2. Okay. Is everybody all right?
Yeah.
All right. Don't, now listen, I'm going to say this again. I'm going to say this a few times. For some reason, some people will do this when I ask if they're with me, and they really don't mean it. And I'm like, I'm going to find out. I'm going to see on the test. So if you're looking around, you're like, I don't understand this, but everyone around me is like going like this. At least half of them are lying for some reason. I have no idea why. I don't know why you want to look good. That's bullshit, right? There's stuff I'm not good at, and if I want to be better at it, and you're like, I don't know how the hell to do this, right? I just happen to know math because I do it every damn day. Shit. So if there is something that you're not understanding, don't compare yourself to other people. Some of them are lying for some reason. And there's some people going to go, my math teacher called me a liar. No, if you're not lying, you're fine. So what about part B? 2 more than the product of 9 and 8. So what does that word product mean? Multiply. So what am I taking the product of?
9 and 8.
So how do I write that?
9 times 8
And I don't just want that, I want, yes, good,
plus 2.
plus 2. And you don't need parentheses because order of operations already knows that this happens first. If you put them, you're not wrong. Just extra.
Can you say it slowly?
Okay.
Slowly.
So 2 more than, right? So you could start it off as 2 more than what? 2 more than the product of 9 and 8. What does product mean? Okay, now you know it's multiplication. What does sum mean? Addition. What does difference mean? Product, multiplication, quotient. Yeah, division. Hey, process of elimination. Right. So if I said the quotient of 7 and 11, that's 7 over 11. I like it. Cool. So 2 more than the product of 9 and 8. Bam. I like it. And it's either way because addition doesn't care what order you do it in. Maybe, maybe. And of course, what is this? What's 9 times 8?
72.
Bam. Okay. So anything up from that sheet that you need to go back over, or I went too fast through, or anything, or you want more examples of? Yes.
So, kind of like what I asked before, the way to know whether you divide first or multiply first, you kind of have to look ahead, right?
Yeah.
Like to see what it would be like in one situation.
Well, no. So if I had this kind of problem, what do you got, Jeff? All right. It's a little bit evil, but what would you do first here?
Write this.
Into parentheses, and it just happens to be division, right? So whatever the hell that was, you would do it first because it's in parentheses, right? What would you do first here? Yeah, there, minus. Multiplication, right? Because what's the only things in there? Multiply, divide. There's no parentheses. And how do you do those? In order. So if I had this, so this would be first here, this would be first here. What would I do first there? Division, because it came first. maybe. So multiplication and division are on the same level of importance. So what determines who's first in that case is just whoever comes first. If there's parentheses, they get booted to the top of the list because that's first thing, parentheses. Doesn't even matter what the operation is inside, they're just automatically first if they're in parentheses.
Can you do more of the
Oh, okay. Now watch this. I love it. Thank you for asking this. Let me show you something kind of cool. I might be the only one that thinks it's cool, but that's all right. I'm used to that. So 2D was that one, so this is going to be like 2D. 2D was the subtraction with unlike denominator. So what if I had this? Sorry. What do you got, Jeff? I don't know. Let's do... No, let's not do that. Let's do... yeah. Let's do that. Ooh, that's gross. I like it. Yummy. Okay, now watch. I want to show you. Now, the one I gave you on the test was on the little sheet was relatively easy because the numbers are small, right? But I want to give you a process you can use every damn time, no matter what. This is not anywhere near as easy. And for some damn reason, the way that teachers like to teach this is take one of them and start writing multiples of it and go insane. Not sure why we advocate insanity. Here's what you do. You ready? Here's what you, no? Some of you guys have the greatest expression on your faces. Stay with me now. Can anyone tell me what the biggest number these have is in common? We talked a little bit last time about the rules of knowing when to divide by. Did we do that? How do you know when to divide by 9? Did we do any of that? Oh, let's do that right now. Kick ass. Before we do this. You all know 5. You know the division rule for 5. How do you know these are both divisible by 5? Because they end in 0 or 5. Okay. Do you guys know, now 2, you all know the division rule for 2. What's got to be true about a number for it to be divisible by 2? It's got to be even. How are we doing? Do you know the division rule for 3?
Yes.
What is it?
All the digits has to.
So did I talk about this last time or did you just know it?
No,
You just know it? Sweet. Do the rest of you guys know it?
Yeah.
So you guys like, what are they saying? How many of you guys know the division rule for 3? Anybody? Okay, now watch. Are you ready? We're going to come back to this problem in a minute, but I like this because this is, I'm telling all my students this because so few students know this anymore. So this number right here is divisible by, I think, did I do all right? Yes, that's divisible by 3.
Yeah.
Now, you know, if you just saw that number, you're like, what the fut, right? I said fut. But what do you get when you add up all the digits,
9.
which is divisible by 3? So the whole thing is divisible by 3. So that is the rule for 3. And think about it. What's 3 times 11?
33.
What's 3 plus 3? 6, divisible by 3, right?
Yeah.
What's 3 times 13? 39. What's 3 plus 9? Divisible by 3, right? And so that just kind of keeps adding on itself. Multiples just add on us. 3, 6, 9, 12. So that rule, if all the digits add up to a number that is divisible by 3, the whole damn thing is divisible by 3. And if you don't trust me, anybody have the calculator out? What is 14,211 divided by 3? 4737? 4737, I think it is. Anybody gonna check me? What is it?
1737.
Yeah, all right. I kind of, that's my one skill, so I'm gonna show it off every now and then. Everybody with me? How many guys have never heard that before? Anybody? Some of you guys? Some of you guys just haven't raised your hand either way, so it's, how many people don't like to raise their hand? Oh, sorry. All right. So watch this. The division rule for 9, you might expect it to be very similar because 3 goes into 9, right? So sure enough, if the numbers add up to a number divisible by 9, then the whole thing is divisible by 9. Right? Now these added up to be 9, so this is actually divisible by 9. Because they add up to be divisible by 9. You guys see that? Okay, I like it. And that would be, what, Jeff? I don't want to do it anymore. Okay. You guys can check it. How you guys doing? do any of you see how these are useful? And is anything I've said so far like really difficult? And is anybody think you've never been told this? Or maybe you forgot it. There's always a chance you forgot it, but unfortunately I'm feeling like there's less and less people being told these things, which is remarkably stupid. You should be like a little bit pissed at least. Like, how dare they take that away from me? This is some human thing we know. Why not tell me I'm a human too? Right? Maybe. Okay. Real quick. Somebody give me a digit.
9.
9. Somebody else give me another one. 7. Keep going. Who? 4? Give me another one. 2. Give me one more. 1. And then I'll end it up with 84. There you go. That's divisible by 4. That number is divisible by 4. As long as the last 2 are divisible by 4, the whole thing is. Why is that? Because 4 goes into 100. Therefore, 4 goes into 104. And then you can just keep adding after that. So as long, if the last 2 digits in any number is divisible by 4, the whole damn thing is. Maybe? All right, last one of these. What about divisible by 6? 6 is 2 times 3.
Both.
So if it's an even number that all the digits add up to be a multiple of 3, it's divisible by 6. So if it meets the 2 and the 3 even, and they all add up to be a multiple of 3, that means the whole thing is divisible. Divisible? What am I drinking? Divisible by 6. Because 6 has 2 and 3 in it. So as long as it meets both rules, it's divisible by 6. All right, some of you guys have zoned out. I'll stop. I'm hoping some of you guys are very interested in this. This is not really difficult stuff, but it's remarkably useful. But I think people went, we got calculators now. So what? We're still the humans here. We got to know some shit, right? I mean, if they keep improving these calculators, that's basically the Terminator timeline. We're going to Skynet, and the calculator's going to get eyeballs and take over. Yes?
So, for it to be divisible by 6, the book says it has to be both 2 and 3.
That's what I just said. So as long as it's even and the numbers add up to a multiple of 3, then it is divisible by 6. That's what I said. You have to meet both, because then you would be 2 times 3, you would be divisible by 6, because you do both. I like it. Okay, enough. So coming back to this. We know these are both divisible by 5. 25, I'll do that one. 5 times 5. What's 80? 5 times what? Come on now. Do you see what I'm saying? We figured out 5 goes into both. So I'm going to break both down using 5. 5 times 16. 5 times 20 is 100. How are we doing so far? So watch this. This is kind of cool. Can you see what this guy needs that this guy has?
16.
He needs a 16, right? You guys see that? So you give him a 16. What does he need that he's got? Another 5. Do you see how you can see? Are they the same now on the bottom? Right? Yes? Do you guys see that? So if you break the bottoms down, what they have in common times whatever other shit there is.
It's like a mirror effect.
Huh?
It's a mirror effect. It has to be the same on both sides.
Both denominators have to be the same. So if you can see what they already have the same, they already have a 5 that's the same, then you can see whatever other shit they got and give whoever's missing something. Anybody have kids? It's kind of better that I don't, because I always give this example. Give them ice cream, and this guy's like, he got more sprinkles. So they give him more sprinkles. He got more ice cream. So you give him more ice cream, and then you're like, screw it, I eat all the ice cream. Nobody gets it. But it's basically, oh, he got a 16. Okay, give him a 16. Oh, he got another 5. So you give him another 5. Now they're both supposedly, theoretically happy, right? You guys sort of get that? And if you already got a method that you like for finding denominators, you don't have to change it all of a sudden. But this will help for eventually when the bottoms are variable expressions and not just numbers. Oh, shit. So that's in our future. So what do I get here? I get 55 over 5 times 80, 400. I like it. Plus 48 over 400 equals 103 over 400. That looks pretty done. All right. I like it. Hey, Mikey. Is that all right? That pretty much covers all the fractions. Either the numbers are small enough you can see what's going to work, or they're too big, and then you can break them down like this. All right. Maybe. Anything else from that sheet you want to look at more, or I want to make sure I cover? No, okay. Looking at your homework, let's see what we got up here. Does everybody remember how to do like prime factorization stuff? Find the prime factorization of this. It almost doesn't matter how you start. I call this finding the DNA of the number. No matter how you chop it up, you end up the same thing at the end. So what's the first thing you see how to break this up?
2 times 2.
Okay, sure. 2 times 2, 42. Let me stop for a second, right? Is 44 equal to 2 times 242? Yes? Okay, so you circle this guy because he's a prime number. He says that's as slow as you can go for him. You can keep going for him. Let's divide him by 2 again. 2 times 121. Anybody know anything about 121? Nope. Again, be careful. I might have not shown you enough of that. The only ones that have rules like that are 3 and 9. What's the rule for 4? The last 2 have to be divisible by 4. Oh shit. What's 10 times 10? 100. What's 12 times 12? 144. What's 11 times 11? Yeah, so that's 11 times 11. So what's the DNA of 484? 2 times 2 times 11 times 11. The only number that those make is 44. That's why I call it its DNA, right? If you're like, dude, no, don't mix biology and math, I'm like, all right, I'm sorry. You don't have to. You guys all right? That's the prime factorization. That is one way to do it. You could have started with 4 times 121, but 4 is 2, and 121 is 11. You would have ended up at the same place. Maybe. Okay. All right. Let me see what else they got on here. Blah, blah, blah. Ooh.
I have
Oh.
one question.
Yes.
So in prime factorization, you do not have to reduce it to the lowest?
I'm not sure what you mean.
Like,
That is the
This-
lowest I can go.
right.
Yes.
So let's say you started with the other one. What did you just mention?
Oh. No. So if I would have started with 4, because you can see 4 goes in, right?
Right.
I'm not done. I would have, if I keep going, I'm going to end up there again, aren't I? What's 4? 2 times 2, what's 121? 11 times 11. See, I end up there no matter what I
So
start
it's the
with.
same.
Yes. So it doesn't matter what you take off the car first. If you take it all the way apart, you're going to have the same pile of parts, right? Then the owner's going to come back and say, what the shit? All right. Okay. So what about this? Let's talk about this. Yeah. What the shit does this symbol mean? Absolute value. I have a shirt that I don't think I can wear to college. It's got the word vodka inside of absolute values. So it's absolute vodka. Okay. I came up with that and then I Googled it and somebody already made a shirt out of it. And I'm like, I got to give you some money. But what does absolute value do?
It removes the term in front of it. Not the term,
So what would the answer to this be?
or.
Well, what would the answer to this be?
4.
Good, right? It's the most single-minded operation. It makes it positive. So it leaves it alone if it's already positive, and it makes it positive if it's currently negative. Why? What's it based on?
Just how far away from 0.
Distance. I love it. So if you're 4 feet away from me, I wouldn't say you're negative 4 feet just because I turn around or something, because then you're like inside me. Quaid. No. So we get that. Total recall? No. Okay. So since 4 is 4 steps away, and negative 4 is 4 steps away. That's why they're both 4. Because it's how far from 0 are you? And you wouldn't say, how far away are you from school? Negative 28 miles. What the hell are you talking about? Are you in the earth right now? You got good reception down there. You guys kind of with me? So you never use a negative for distance. So that's why absolute value is based on distance. That's why it's always positive, unless, what's the one number I can put inside so the answer is not positive? Ooh. 0, because 0 is technically not positive or negative. So it's kind of stupid, right? 0 is 0 away from itself. Okay. I like it. So is that all right? You're going to see some absolute value stuff. So what if I had this? The biggest mistake people make with absolute values is a problem like this. Somebody will write 2 plus 7 and say 9. You can't do an absolute value of a number until you know what the shit the number is. So they're sort of like parentheses that somebody's ironed out, right? So you have to do what's inside first. What is 2 minus 7? Negative 5. And what's the absolute value of negative 5? 5. So just like they're in the exact same place as parentheses in the order operations. I like it. Yes?
Do you do parentheses or absolute value first?
So when you, oh, wait a minute.
If it's in the same problem.
Yeah.
So the only way they could show up in the same problem would be either something like, let's see, like this, right? Because then you would just do this, because you do in the parentheses first, so you do this first inside. Or they're going to be inside here, right? Right? In which case you just do the whole inside first, and then you worry about the absolute value. Does that make sense? So they're not like ever competing. I know what you're trying to get at, but they're never going to be kind of like competing with each other. One's in the other one, or the other one's in the other
On
one.
the opposite side or the equal side, you have one each.
Oh, don't bring equations in yet, dude. You don't want to do that. Absolute values inside of equations gets a little bit freaky. Right? In fact, watch this. You can handle this. I shouldn't even have said that, because now I've made you guys think it's so hard. But absolute value of what is 2? You can do it. 2 or negative 2. It's 2 answers, right? So when we get to these, of course, they're not going to be like this. But the basic idea is there's almost always 2 options if there's an absolute value inside of an equation, because it can make positive and negative become the same thing. Right? So that's later. Okay. Blah, 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 blah. Oh, okay. Let's do this. Yeah. All right. Let's talk about 0 just a little bit more. What screws us up the most in algebra is, to be honest, the most direct things for just computation is negatives and 0, right? Would you guys agree? No? You're probably thinking, dude, you have no idea what messes me up. And I'm like, yes, I do. But, so if I had something, now I'm going to start kind of stupid here. You ready? What is 6 divided by 2? That's amazing. Explain to me why using multiplication.
2 times 3.
Yeah, 6 divided by 2 is the number 3, because the number 3 is what you multiply by 2 to get 6. You with me? So that's sort of like a lawyer saying this problem or something. The party in the first part. Yeah. But you guys understand? Now watch. This is why I said it like this. What is 6 divided by 0? It would have to be the number, so that when I multiply it by 0, I get 6. Is there any number defined to do that?
No.
So therefore that is undefined. Does that sound familiar to anybody?
Yeah.
When you can't divide by 0, and what do you call it when you do? But now you see the complete story. You should have been like, why the shit do you people call it undefined? And if your teacher couldn't answer you, psst, get out of this profession. So the reason we call it undefined is because of the exact kind of problem it's in. The number that's defined to multiply 2 make 6 is 3. That's what it's defined to do that. But there is no number defined to multiply by 0 and get 6. So we call it undefined. That's not very mysterious, right? Some of you guys might have called this, anybody else call this anything besides little jackass? Infinite sometimes. Some teachers might call it infinite. I don't know, anybody ever do that? When we get to lines, this would be a straight up and down line. Remember rise over run kind of business? Yeah. So that's like an infinite line. Holy shit. So that's sort of like where the idea of infinity came from. But undefined is just what it is directly, based on how we look at things. Okay, maybe. But what is 0 divided by 6? And again, look at it the same way. What number do I multiply by 6 to get 0? 0. So there's no problem. This is, I have no money, and there's 6 of us. So we each get 0. Okay, see, that makes sense. This one is, I got $6, and nobody's there. Not even me. So this doesn't make any sense physically. Do you see what I mean? That's like, okay, how do you have $6 if you're not there? And I got $6, and I don't exist, and nobody else does. Holy shit, but this is fine. I've seen something like OK and NO. Have you guys ever seen that? A 0 on top is OK, a 0 on the bottom, NO, no. But I kind of don't like that kind of shit because it takes you away from the idea. The idea itself is not difficult. You just have to stop yourself when you hit this and see which one makes sense right now. Maybe? Okay. Okay, I think that's enough for today. Anybody, I got a copy of the first homework assignment. Does anyone have any issues with the book? You want a copy of the first homework assignment? Okay, wow. Are you all having issues with the book? Is that what's... In what way? Oh, you just haven't downloaded it? Okay.
So you want us to print that each time we have a homework assignment? Because I just was writing out.
No. If you're able to access the book, just do the work. You don't have to print this shit out. I know what it is already, right? No. Has anybody else bought that blue book?
I don't know.
Oh, good. There's like a blue book, a Math 90 lecture book.
I think that's what's labeled in the bookstore, under your course number.
What is it?
I think that's in the bookstore under your course number.
Don't get that. It's like, what is that, $11?
Yeah.
It's built for the book that costs $180. It's not built for my food. So I am sort of gonna use some of that, but I'm gonna print it out for everybody. Because I have to change it a little bit because it's not the same. Who needed it in this room here? Anybody? You need it back there? Who here? You? And back there behind you, there's one.
Are we able to print that from
online? Yeah. Oh, shit, you need one? Shit! Okay. So that was really just for people that cannot, for some reason, print it out, in which case you desperately need to come see me so we can figure something out. Otherwise, that's enough, I think, guys. Is that all right? You feel gypped to let you out early?
Yeah.
Yeah, you do? All right. I've had, trust me, I've had people get upset.
What is your slang?
You guys know the word gypped, right? Yes.